This is homework 6, question number 3. It says a projectile is fired horizontally from a gun that is 45 meters above flat ground. Strikes the ground a horizontal distance of 750 meters from where it was fired. A says how long does the projectile remain in the air. B is what is the initial velocity of the projectile. And then C says find the following just before the projectile hits the ground. And that's going to be Vx right here. I know you guys can't really see that, but that's Vx. That's V sub y. And then that's our overall velocity. That's going to be the resultant vector. And then that is our angle theta, the horizontal that it is going to strike the ground at. All right. So this is going to be very, 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 very similar to question 1, except in question 1, it says it's thrown horizontally at a velocity from a cliff a certain height above the ground. In this one, it says it strikes the ground a horizontal distance of from where it was fired. How long does it remain in the air for? And then what's the initial velocity of the projectile? So the only difference on these two is this. A says I'm going to move this down here. A says how much time does it take to reach the ground from a certain height. You're going to do the exact same thing to find the height on this one. All right. B says how far from the base of the cliff does the stone strike the ground? Okay. Well, it's how far does the stone strike from the base of the cliff given the time that we had to find in part A and this velocity. Well, in this one, it says what's the initial velocity of the projectile? Well, we're given how far it goes, okay, and we calculate the time here. So we're going to find out what the initial velocity is there. And then C is going to be exactly the same. So I'm not going to bother working part C out on this one. I'm just going to work part I'm going to make up some numbers and then work parts A and B. Only A because I've got to work part A in order to get part B anyways. So we're going to go ahead and say that instead of 45 meters above the ground, well, first off, I'm going to draw my little picture here. So here's our cliff. There we go. And we're going to draw it horizontally off. So it's going to look something like that. And I'm going to pretend that this is actually flat. There we go. That's not much better, but okay. So I'm going to give myself an initial, nope, I'm not going to use an initial velocity. I'm going to say that it strikes the ground 1,000 meters away. So that's 1,000 meters. All right. And instead of saying that the cliff is 45 meters high, I'm going to say that my cliff is 50 meters high. Okay, that's going to be different enough to give me sufficiently different numbers. So if we want to know how long the projectile remains in the air for, we know that there is some velocity here, v sub x, which is unknown. I know that at this point, my initial velocity within the y direction, so I'm going to put viy. I don't know if you can see that, but that says v, and then it's got a little I and a little y for my velocity initial within the y direction. So that's going to be 0 meters per second. Note that that is at that point. My x velocity will stay the same the entire trajectory. My y velocity is going to be slow here. All right, it's going to be 0 at the beginning, and it's going to speed up as gravity brings it towards the earth. All right, so I know in the y direction to find time that my initial velocity is 0 meters per second. Delta y is going to be equal to 0 meters minus 50 meters. The reason it is 0 minus 50 is because it's final position minus its initial position. All right, so if this were our origin, it would end up at the 0 or on the y-axis, and it begins 50 above the y-axis. So 0 minus 50 gives us negative 50 meters. All right, and then the last thing, not the last thing, but the last piece of information that I know is that acceleration is negative 9.8 meters per second squared. All right, so that's 3 knowns for what's going on in this direction. I do not know what my final velocity is. I don't really care what my final velocity is at this point, although I would want to solve that for part C. And I want to know how long it's in the air for, because that's going to determine how fast it must have been moving up here in order to cover that distance in this time. So I'm going to go ahead and just circle that and cross it out. And the equation that I'm going to use is going to be my second kinematic equation. Since we're looking at it in the y direction, I'm going to say delta y equals velocity initial in the y direction times t plus 1/2 at squared. All right, and I could have had VIT minus 1/2 of gravity times time squared and called gravity positive. I could have probably also put plus 1/2 gravity times time squared and had gravity negative. It's just acceleration. It's a special acceleration, so I'm just going to say 1/2 at squared. So delta y is negative 50 meters because it is going down 50, and that equals VIY is 0. So I'm going to go ahead and just cancel those out and not even bring them down. Plus 1/2 times negative 9.8 meters per second squared times t squared. Do not forget that your t is squared here. So negative 50 meters equals negative 4.9 meters per second squared times t squared. All right, I'm going to divide both sides by negative 4.9 meters per second squared divided by negative 4.9 meters per second squared. It's going to cancel out on the right side, and that leaves me with t squared equals 50. My meters are going to cancel out, and my seconds squared is going to move up to the top. So it's going to be 50 over 4.9. I know that's approximately 10, but I'm going to go ahead and work it out nonetheless. So 50 over 4.9, let's go ahead and turn on the calculator. 50 divided by gives us 10.2, right? So that's sufficiently different. So t squared equals 10.2 seconds squared. I'm not done yet. I'm going to take the square root of that and say t equals the square root of 10.2 seconds squared. Make sure it's all under the radical sign. And we're going to go ahead and calculate that out since I cannot do that in my head. It's 3.19. All right. Our units, since it was seconds squared here, the square root of seconds squared is seconds. So it has 3.19 seconds to fall. All right. So in this case, we have that it is traveling 1,000 meters, delta x is 1,000 meters in 3.19 seconds. All right, which means that if I want to find my velocity within the x direction, I'm going to say Vx equals delta x divided by t. Go ahead and plug everything in. 1,000 divided by, don't forget your units, 3.19 seconds. And that gives me 313, so 313.0 meters per second was the initial velocity. All right. I'm not going to work out the last part to this. It says find the following just before the projectile hits the ground. Vx, Vy. Vx is going to be the same thing for part C. For that one, it would be the same velocity as the initial velocity within the x direction. Vy final. Obviously, it is not 0 meters per second when it strikes the ground in the y direction. Otherwise, it wouldn't have moved in the y direction and it would never hit the ground. So you're going to have to do the same thing you did in part 1C. See the other video for that, where you find delta or Vf at the bottom of it. You're going to then make your triangle. I'm going to draw that really, really quickly. So you make your triangle with this Vx. Vy is going to be directed downwards because it is falling. Okay, this is going to be Vy final. Whatever you calculate for there, you're going to use those in the Pythagorean theorem to find V here, and then you're going to use the inverse tangent to find that angle. All right.